Okay, I know this is going to become as a shock to some of you, but this problem here, I screwed up this part. I screwed up this part because I said, what's the I said, well, you've got the energy down here, and then how high is it going to go up to here? And I don't know if I gave you the right answer or not because I just because we can take it from here. The key to this one was A, B, and C were fine. We were fine there. I got to thinking right after class. I went and looked at it again. I said, well, wait a minute, this should be easier than what I said because I said, okay, well, you take all its energy down here and then translate that going up here. That's not going to be right. It's not going to be right because we've got the spinning thing going on. All right. The way you think about it is because I was wanting to start from here, and of course you would start from here. You'd start from here's your initial energy, then it comes down here, and then it comes up here. Now, here's where I was stuck. I was like, now wait a minute. Because what I gave you, if you did it, you're going to get that the height that it went back up to is 1.4. All right. It's going to be this H max. Now, what's happening? It comes down here, it rolls, boom. All right. Now then, once it pops up here, it's still spinning. There's nothing there to stop it from spinning. It's still going to be spinning. However, the velocity is going to be going down to 0, but the spinning will never stop. All right. So to get the maximum height, so here's what we do. Here's the way this problem 13 part C should have been. All right. And I will, problem 13, part C. This is what we're doing. We've got MGH initial, all right, minus the 1/2 I omega final squared, which you got before. 1/2 omega final squared is equal to MGH max, the maximum height that it went to after. Now it makes sense. Now it makes sense. And you got omega final from what the work that you did before. All right. So that's the way you do it. All right. I just wanted to make sure we got that. Okay. Because I was like, wait. Because if you did the way I did it, where you had where you said 1/2 mv squared plus this guy, you're just going to wind up with MGH naught. Well, yeah, you're putting all the energy back in. Duh. No. The rotating takes energy out of the system. And so, but when it's going back up, there's no torque on it to stop it from spinning. So therefore, there we go. I knew. I was like, uh-oh, you didn't think about this right. And there we go. Now I thought about it right. Okay. All these values are given and calculated this value in part B, I guess it was. What part was it? I like this. I do like being able to do a YouTube video of it every once in a while. Part D, because you've got the maximum rotational speed from part C, and then you just plug that in this one. And depending on, and as Dylan pointed out in class today, it depends completely on your what object they give you. Some of you might get a solid disk, which is mr squared. Some of you might get a hoop, which is 1/2 mr squared. Some of you might get a hollow ball, which is 2/3 mr squared. Some of you might get a solid ball, which is 2/5 mr squared. And I got to make sure that I give you all those moments of inertia so that you'll be fine on your exam. It's not like you're going to have to compute a bunch of them. Maybe and it's not like you might even need it, but just so we have, just so it's there. All right. Okay. Enough on that.